Let's take a look at another example now. I'm calling this example number 2. So now we're going to look at, I should probably put that on here so you have it when you look at the video. So this is going to be example number 2. And what we're going to be considering is the function y is equal to 3/2 the cosine of 2x plus pi, and our mission is to graph one period of this function. So as usual, let's identify the information that we have here, and we can see we're going to have a lot going on in this graph. A is 3/2, B is 2, remember it's the information right in front of the x, and now C is equal to pi. So we're going to have a change in our amplitude, we're going to have a change up in our period, and this C says we're going to have some sort of phase shift. We're not going to be starting at 0, we're going to be starting at another angle. So our amplitude is equal to 3/2. It's the absolute value of this, so it's positive 3/2, or we could consider it as a mixed number 1.5. For graph purposes, that might be a little bit easier to envision. Now, our period for cosine is 2 pi over b. In this case, our b is 2, so our period is just pi. So that says where normally in 2 pi at 360 degrees we would just have one complete cycle. Now we're going to have 2 because our period is just pi. And remember, in order to generate our 5 key values on our cosine curve, we're going to take this period and we're going to divide it by 4. So we have pi divided by 4. That's the increment we're going to add to generate our 5 key angles that we're going to consider. And then we have this phase shift. So I'm going to abbreviate it, PS, for phase shift. And phase shift is C over B. So in our case, C is pi and B is 2. So our phase shift is pi over 2. So we're going to be shifting 90 degrees or pi over 2. Now, what direction are we shifting in? Because our C was positive here, that means we are going to shift to the left. Remember when we learned transformations in pre-calculus, whenever we have a positive value within the parentheses, we're going to go to the left. And if this was a negative, which it is not, but if it was negative, we would go to the right. So now we've identified all our information, and let's generate our angles here. So where we started at 0 when we didn't have a phase shift, here we're going to start at negative pi over 2. And negative pi over 2, because remember, we're going to the left of 0 in negative territory. Let me switch markers here because I'm not going to be able to fit. So for the next angle, we started our negative pi over 2, and now we add this increment of pi over 4, our period divided by 4. And this gives us negative pi over 4 through the magic of fractions. Remember, this class, you've got to be strong with your fractions, so make sure you understand how to add those there. Next angle, we have our negative pi over 4. Again, we add our increment of pi over 4. Negative pi over 4 plus pi over 4 is 0. Now we have 0 plus pi over 4. Gives us pi over 4. So we have 1, 2, 3, 4 of our key angles. And for the last key angle, we have our pi over 4 plus our increment of pi over 4. And this gives us 2 pi over 4, which is going to just be pi over 2. So now we have our 5 key angles, and we're going to take these angles and we're going to evaluate them for the cosine function. So as I stated before, Because of how we have generated these angles, it isn't necessary to do the substitution of negative pi over 2 into the x to actually do that algebra. You could, but because of how we've chosen these, this is going to be, if we were to do that, this would be the cosine of 0. And we know that the cosine of 0 is 1. For negative pi over 4, this is going to be the value we would get for the cosine of pi over 2, which is 0. For our value of x, this is going to represent the cosine of pi. And this one we could do fairly easily by substitution. If we put 0 in for the x, 2 times 0 is 0, and then 0 plus pi is pi. So you can see we are really looking at the cosine of pi, which is negative 1. And then the pattern would continue. This would be comparable to the cosine of 3 pi over 2, which is 0, and then the cosine of 2 pi, which is 1. So we have our values, and now notice this is just based on the cosine of these angles. In our example, we have changed up the amplitude. So now this 3/2, which is in front, each of these values has to be multiplied by the 3/2. 1 times 3/2 is 3/2. This would be 0. That would be 0. I like to do the easy math first. This would be negative 3/2. And then this would be 3/2. So now we have our x values and our y values, and we can go and plot these on our graph. So I've made my scale here. Hopefully you can see it. You might have to enlarge your screen. My x and y. X, this is in increments of pi over 4. So 0 pi over 4, 2 pi over 4, which is pi over 2. And then negative pi over 4, negative pi over 2. And my y-axis, this is 1, and this is 2, and in between is 1.5. So let's get graphing. At negative pi over 2, oops, I'm off the screen, negative pi over 2 here, we are at a value of 3/2. So at negative pi over 2, we are up here. Now, at negative pi over 4, we are at 0. When our x is 0, we are at negative 3/2. We are down here. When x is pi over 4, we are back at 0. And then at pi over 2, we are up here again at 3/2. So if we connect the dots, we were required to graph one period of this curve. So this would be it. So this is what we were required to do. We could see that we absolutely could continue this graph. I'm not going to do that here because this is what we had to do. So again, just like with the previous example, I think it's useful to take a look at what we have here in terms of our regular plain vanilla cosine function. So the regular cos is in red. It's this line here. And the function we just graphed is in blue. So first let's take a look at what we actually generated, because we generated one period between negative pi over 2 and pi over 2. So here is what we just graphed there. We should recognize that from what we just did. And then this red is the piece of cosine of x. So this looks a little bit weird to me. So let's expand the view and to get a better perspective of what's going on here. So I would like to focus between 0 and 2 pi, because 0 and 2 pi, we know and love that from what we've looked at in the past. So we can see between 0 and 2 pi, which is our regular period for cos, here is our cosine function, starting at 1, decreasing at pi, and then ending up back at 1, one complete cycle, one complete period between 2 pi. And this is what the function we just graphed would look like. if we look at this, we can see within 0 to 2 pi, we have 2 complete cycles. And remember, we changed up our period and said that the period was pi for this. The other change up is in our amplitude, where we were at 1 for a max and -1 for a min. We're slightly higher at 1.5 and slightly smaller at -1.5. Not a dramatic change, but there was a change in the amplitude. The other thing we can see here is this phase shift. Our phase shift was pi over 2 back. So we can see here where normally we would start at our max at 0. Here we shifted it backwards to pi over 2. So instead of starting at our max here, we shifted the entire graph back and we started at our max at -pi over 2.